long-endurance multi-intelligence hybrid air vehicles in an integrated maritime surveillance role. A product introduction to Bakamla, Indonesia. Located at Cardington Airfield, Bedford. The original, 100-year-old, R100 and R101 rigid airship hangars at Cardington Airfield are home to Hybrid Air Vehicles Limited and the Airlander. The Airlander story. Hybrid Air Vehicles established in 2007. Subscale Hybrid Air Vehicle, HAV development, 2007 through 2010. Awarded U.S. Army Long Endurance Multi-Intelligence Vehicle Program 2010. LEMV first flight, the 7th of August 2012. Airlander returned to the UK 2013. International Traffic and Arms Regulatory Clearance 2013. Airlander developed in compliance with EASA regulations for civil and military roles, 2014 through 2016. Commenced return to flight program May 2015. First flight scheduled for July 2016. Airlander is the largest aircraft in the world at 92 meters or 302 feet long. It is powered by four 325 horsepower direct injection turbocharged aviation diesel engines with thrust vectoring capabilities. It exhibits exceptional fuel economy for an aircraft of its size and multi-mission capabilities. In a persistent surveillance role, Airlander has the ability to remain airborne for up to 5 days, monitoring vast maritime patrol areas on a 24/7 basis. Airlander is a flexible multi-mission, long-range aircraft that can be utilized, not only for surveillance operations but during natural disasters, emergency response, disaster relief, and search and rescue. Its ability to operate from remote locations without conventional airports and runways make it unique for an aircraft of its size. Roles also include crowd monitoring and policing. Mission systems available enable Airlander to provide real-time data and communications transmission and receiving for both civilian and military roles. Airlander can also be adapted to a cargo carrying role for national development projects and logistical requirements in remote inaccessible areas of Indonesia.
This hybrid airship combines several aeronautical technologies, including some used by planes and helicopters to maximize its efficiency.
The hull has got 38,000 cubic meters of space inside it, which is mainly filled with helium, lighter than air. That gives it lift, and about 60% of its lift comes from that. Up to 40% comes from having a wing shape, having an aerodynamic shape, and that gives it extra efficiency and means it's very controllable.
Lift is provided in three forms: buoyant lift from lighter than air helium, aerodynamic lift via forward movement of the HAV, and vector thrust from the four engines, two at the rear of the HAV and two at the forward section. The flight cockpit and payload bay modules are located on the underside of the hybrid air vehicle. The hybrid air vehicle employs fly-by-light flight control systems that exhibit a distinct advantage over conventional systems in a vehicle the size of Airlander. Mission Sensor Systems, C4ISR, command and control consoles and operator seating arrangements are shown in a mock-up simulation of a potential configuration. The first view is looking forward with the second view looking aft towards the boarding boat storage bay area. An artist's impression shows the boat deployment feature located aft of the flight cockpit and payload bay modules. C4ISR mission sensor systems. Generalized equipment options. The hybrid air vehicle's capability to accommodate and support mission system sensors is the most significant of any airborne platform in the market at this time. Inherent capacity available for backup sensor systems enhances long-duration performance and reliability, coupled with its ability to remain airborne and manned for 5 days continuously. It is capable of an hourly aerial surveillance coverage of more than 1 million square nautical miles. This equates to approximately 7 million square nautical miles in a 24-hour period. The ability to operate from remote forward operating bases (FOB) without the requirement of a conventional airport and runway is unique for a vehicle of the Airlander's size and capabilities. As seen in this takeoff phase, the Airlander exhibits short takeoff and landing (STOL) capability, enabling it to clear high obstacles within close proximity of the operating base. When in normal flight, the Airlander cruises at 80 knots or 148 km per hour and loiters at 20 knots or 37 km per hour. Operating altitude is typically 7,000 feet or 2,134 meters. The Airlander itself is capable of a maximum operating altitude of 20,000 feet or 6,100 meters. However, oxygen or cabin pressurization is required for the crew at that altitude. In this stage of the flight, the Airlander is in hover mode and pivoting on its vertical axis while being observed by a chase helicopter. This flight mode would be typical of the Airlander remaining on station in maritime surveillance and observation mode prior to interdiction by maritime surface craft and personnel. Within Indonesian territorial waters, there are extensive natural resources that require protective maritime border monitoring and surveillance. These natural resources are crucial to Indonesia's economy and the benefit of the population. A September 2012 recording of global shipping shows the concentration of vessels passing through Indonesian territorial waters. The Strait of Malacca is one of the most important shipping lanes on the planet. It is the shortest route between the Pacific and Indian Oceans. Approximately 40% of world trade passes through the strait each year, including most of the crude oil going to China from the Middle East. The narrow straits are also vulnerable to piracy, requiring the need for constant maritime surveillance. Indonesia's maritime area is vast, and the task of securing its borders is a significant challenge for the respective government stakeholders. Spread over such a large area, it is difficult to economically protect the country's sovereignty. Many threats easily go undetected. A continuous airborne surveillance system can monitor crucial maritime areas for any intrusions and provide the necessary alert notifications to the appropriate authorities in real time. Such warnings can be either public or military depending on the severity. When an intrusion has been determined to be hostile, based on real-time data and monitoring, the appropriate rapid response forces can be mobilized. A crucial consideration is the distance that a rapid response force may have to travel to the intrusion point. The long-endurance multi-intelligence hybrid air vehicle has the ability to remain on station until the rapid response forces arrive at the intrusion point. Returning to base after a successful mission, the Airlander approaches the operating base prior to landing. The landing system comprises pneumatic skid tubes, located on the lower side of the two outer hulls. These skid tubes provide the ability to operate on multi-surface ground conditions, including an amphibious capability. The skid tubes are retracted into a reduced size during flight for a clean in-flight drag-reducing profile.